Good evening, ma'am. Myself, Muhammad Asif from Computer Science Engineering, and my today's CA assignment topic is this problem: determine the constant B and C and solve an if A0 is equals to 0, A1 is equals to 1, A2 is equals to 4, A3 is equals to 37. Satisfy the recurrence relation AN plus 2 plus BAN plus 1 plus CAN is equals to 0, N greater than is equals to 0. Let's move on our topic, ma'am. Here our given relation is an plus 2 plus ban plus 1 plus can is equals to 0. Consider this is equation 1. Here our condition is for n greater than or equals to 0. Then if n greater than or equals to 0, then we get n is equals to 0, n is equals to 1. Now for n is equals to 0, let's check one by one. First n is equals to 0. Substitute n is equals to 0 in equation 1. Here equation 1 is an plus 2 plus ban plus 1 plus can is equals to 0. Substitute n value is equals to 0 in equation 1. Then we get a2 plus ba1 plus ca0 is equals to 0. Now it's time for n is equals to 1. Substitute n is equals to 1 in equation 1. Then we get a3 plus ba2 plus ca1 is equals to 0. Consider equation 2 and equation 3. If n is equals to 0, that is equation 2. If n is equals to 1, that is equation 3. Let's move on another slide, ma'am. Then we have values a0 is equals to 0, a1 is equals to 1, a2 is equals to 4, a3 is equals to 37. Now from equation 2, we know that equation 2 is a2 plus ba1 plus ca0 is equals to 0. Substitute the above values, that is a0 is equals to 0, a1 is equals to 1, a2 is equals to 4, a3 is equals to 37 in equation 2. Then we get b value, b is equals to minus 4. From equation 3, substitute a0 is equals to 0, a1 is equals to 1, a2 is equals to 4, a3 is equals to 37 in equation 3. Then we get c value. C value is minus 21. Now we know that b value is equals to minus 4, c value is equals to minus 21. From equation 1, an plus 2 plus ban plus 1 plus can is equals to 0. We already know that b is equals to minus 4, c is equals to minus 21. An plus 2, substitute b value, c value in equation 3. Then an plus 2 minus 4 an plus 1 minus 21 an is equals to 0. Substitute b is equals to minus 4, c is equals to minus 21 in equation 1. Put n is equals to n minus 2 because n is greater than or equals to 0. Then we get now n value is equals to n minus 2 in equation 1. Then we get an minus 4 an minus 1 minus 21 an minus 2 for n is greater than or equals to 2. Let's consider this equation is equation 4. Now the characteristic equation of equation 4 is k is equals to 7 comma minus 3. Then we solve equation 4. Characteristic equation is nothing but roots. Then we get k value is 7 comma minus 3. The general solution is an is equals to a1 7 power n plus a2 minus 3 power n. We know that this is the general solution. Here our initial conditions are a0 is equals to 0, a1 is equals to 1. Let us consider one by one. If a0 is equals to 0, nothing but n is equals to 0. Substitute in these values in our general solution. a1 plus a2 is equals to 0. If we consider a0 is equals to 0, then we get a1 plus a2 is equals to 0. Now we consider a1 is equals to 1 in above general solution. Then we get a1 7a1 minus 3a2 is equals to 1 for n is equals to 1. If n is equals to 0, we get a1 plus a2 is equals to 0. Let us consider this is equation 5. For n is equals to 1, we get 7a1 minus 3a2 is equals to 1. This is equation 6. Solve equation 5 and 6. From equation 5, a1 plus a2 is equals to 0. Then if we solve this equation, we get a1 is equals to minus a2. From equation 6, 7a1 minus 3a2 is equals to 0. If we want to find a1 and a2, here a2 is equals to 7 into minus a2 minus 3a2 is equals to 1 minus we get a2 value. Here a2 value is minus 1 by 10. Same like this we want to find a1 also. Here a1 is a1 is 1 by 10. Now we know a1 value and a2 value. Now an is equals to a1 7 power n plus a2 into minus 3 power n. We know that a1 and a2 values. Substitute a1 and a2 values in above general solution. Then we get the final solution. An is equals to 1 by 10 7 power n minus 3 power n. This is the final solution. Thank you, ma'am. This was presented by Mohammad Asif from Computer Science Engineering Department, CSCD section, Srinivasa Ramanujan Institute of Technology, Anantapuram. Thank you, ma'am.